Let's begin with the topic S1.1, and the name of the topic is models of the particulate nature of matter. In this unit, we are going to talk about introduction, to the particulate nature of matter. This is the first unit of S1, and the S1.1 topic name is Introduction to the Particulate Nature of Matter. This topic consists of 4 subtopics. So first we are going to talk about the chemical elements, compounds, a very basic we are going to discuss, and we are going to discuss about mixtures. The second subtopic consists of how we are going to separate the mixture. Topic is separating mixtures. The third topic is change of state. And the fourth topic is average kinetic energy. Right? So without wasting time, let's start with the first part of the topic, that is chemical elements, compound, and mixture. So let's begin with this one: elements, compound, and mixtures. Very basic topic. Let's try to understand what IB is expecting from us in this particular section. So when we talk about element, compound, and mixture, so first of all, let's say if I'm saying sodium, right, or if I'm saying chlorine, right, these are atoms, right? So if I'm taking a sodium metal, what we will find? We will find that in this particular metal, all atom is of sodium atom, right? I can say all atoms are sodium. There is no other element. So they are the pure form, right? Pure. Even if I'm going to combine these two, let's say sodium and I'm going to combine chlorine, we get a sodium chloride, right? Now this is a compound, right? It's a compound. Let's say this is the sodium chloride crystal. So if the sodium chloride crystals are there, what we will find? We will find that in this there are all the particles which are present. All particles are of NaCl, right? So this is also a pure form. So can I say that these two, I mean element and compound, they are the purest form. purest form of substance, right? Whereas mixtures will be impure, impure substance, right? But when it comes to defining the term, we have to be very clear. And as we have seen that element are substance made up of one kind of atom, made from one kind of atom. So that means atoms further you can't break. This atom is the smallest part. So that means atoms cannot be chemically broken down into simpler substances, right? So this is not possible, right? Let me go up. So but element can take part in chemical bonding, right? And they can do all kind of reactions. So we can say that element take parts in chemical reaction in which new substance, right? As we have seen here, sodium and chlorine combined, and we got a totally new substance, right? New substance are made in processes that most often involve energy change, right? Let me show you one image. So what we are seeing here in this diagram, we are seeing that uh, sodium and chlorine, see how they are looking like. They are totally different. So in the case of chemical reaction between sodium and chlorine, they have very different arrangement. So first of all, chlorine, this is a gas, this is a metal, right? And after that they have formed a salt crystal, right? NaCl. And the arrangement of chlorine and sodium is very unique. And what is the ratio between sodium and chlorine? So if you see the ratio is 1:1. So whenever you will take one part of sodium, one part of chlorine, you will make NaCl, which is very unique. This is called compound, right? So can I say that in these reactions, atoms combine together, right, in a fixed ratio. Ratio is fixed, right, producing compound, right? So we have seen that elements, they chemically combined and you will get a compound. So in this compound, what we are getting, that two atoms are chemically bonded. So there is no chemical reaction. It's a chemical bond formation. So I can say that compounds are made from two or more element, right? Chemically bonded. So there is a kind of chemical reaction between, sorry, a kind of chemical bonding between them. And you will find that the new substance which is formed, like NaCl, which is totally new. So sodium and chlorine, we are getting NaCl. The property of this particular compound is totally different from the individual. So can I say that the properties of compound can be quite different from the element that forms them. So sodium, you are seeing how they are, chlorine, you are seeing how they are, and at the end we know the properties of NaCl. Let me show you a diagram of NaCl crystal. So how these look differently. Let me bring this image. This image will help us to understand. Right? So see, this is lots of substances are here, right? And they look totally different. Let's see how elements look like in a diagram. Here in this particular diagram, what we are seeing, that this is a mixture of elements, like the blue balls are of different atom, white ball is of different atom, right? So mixture of elements, maybe there are 2-3 metals. Compound, you can mix water, you can mix salt. Let's see, water and salts, sodium metal, iron metal, aluminum metal, right? There is also possible, like you have put it sodium plus water plus salts, anything is possible, right? So mixture is a very versatile, these all are what? These all are mixtures, right? But when we say mixtures, what are they? How we can define them? So we can say that mixtures are substance that contain more than one element or compound in no fixed ratio. In any ratio you can you can add. There is no restriction of how much you are going to add or mix, right? So mixtures are very unique thing. Why unique? Because you can mix anything and you will find that there is no chemical reaction. It's a physical mixing. So can I say that the element and compound are interspread with each other, right? They are mixed but are not, I'm saying not, chemically combined. That means there is no reaction going on. So what we can say, so this means that compound of mixture retain their characteristics features, right? That means this means that compound of a mixture retain the same characteristics, properties, better word, properties as their pure form, right? Like example I can say the gas nitrogen and oxygen, right? When mixed in air, it retains the property. Oxygen is not going to become something else, right? So you will be you, whether you are with your group of friends or group of people, right? Wherever you are an unique individual. In the same way, when you mix something in a physical mixing, there is no properties are not going to change. So when mixed in here, retain the same characteristic properties as they would have if they were separate, right? So even they are in a mixed form, the property is not going to change. Other thing, you can say that substance will burn in air because of the oxygen, because oxygen supports burning. So in the mixture, if let's say oxygen is there, so particle is getting burnt. That means because of the oxygen. So you can say that substance will burn in air because the oxygen present in the air supports burning. So that is possible, that whatever substance are there and they are getting burnt, they are getting mixed, and they are burning because of the oxygen, right? So let me show you an image where a different kinds of mixtures are there, right? So you can see here in this diagram. Let me bring it in a normal size. Just give me a second. Yeah. So you can see these are the substances. A mixture can be form of an element, right? Mixture can be formed mixing 2-3 compounds. So we can categorize the mixture into two forms, where you are mixed in a very uniform manner, which is called homogeneous, or a kind of mixture where things are not uniformly mixed, right? So I can say mixture there's a two category I'm going to make. Homogeneous and heterogeneous. So in case of homogeneous, when we say it's, just now I said it is uniformly mixed, right? So I can say a homogeneous mixture has uniform composition and properties. Throughout, like if you have mixed, let's say, sugar and water, right? You're getting a sugar solution, right? So this sugar solution is going to be sweet, right? And sweetness is throughout the solution. The sweetness is not going to change, right? Another example of homogeneous mixture is air. Bronze is an alloy, right, which is a homogeneous mixture. When we talk about heterogeneous mixture, things are are not uniform, right? So we can say a heterogeneous mixture has non-uniform composition. So composition is not fixed. They are not fixed. So its properties are not same. Are not the same throughout. Example, concrete. When we say concrete, there are so many things. There is a sand, right? There is water, there is cement, there is rocks also, right? So things are not fixed here. We can also say orange juice, right? Mango juice. These all are heterogeneous. So it is often possible to see the separate components in the heterogeneous mixture, but not in a homogeneous. There's a possibility you can see the things in heterogeneous, right? But not in homogeneous thing. So let me write as a note point here, which is very important, that it is often possible to see the separate components in heterogeneous but not in homogeneous, because things are purely mixed, right? That's the reason. Majorly we have to focus on here how we can separate the mixture, right? So let's talk about how to separating mixtures, right? So why we are separating? We are separating because we want to get our individual component from it. Let's say you have mixed sugar and water, so now you want the sugar back. So there must be a method to do the process in a reversible manner, right? So why we are separating? What is the reason? We want to get our components, right? So we can say the component of a mixture keep their individual property, right? This means that we can often separate them relatively easily, right? Now when we talk about what are the that we can separate, then what are the separating techniques as per the latest syllabus? So the separation techniques takes advantage of of a suitable difference in the physical properties, and we are going to use that physical property to separate them. Properties of the component. So whenever you want to separate something, we use the physical property. We are using some of the main property. Like when we talk about physical property, what are the physical properties? Boiling point, right? Then melting point, then solubility, then density, and sometimes we can use magnetic property also. If it is a magnet, if it is a metal, magnetism. So these physical properties can be used as a tool to separate the components of mixtures, right? Components of mixture. Okay, let me change my slide. We'll discuss about a basic solution which we generally separate, like separating salt and sand, right? Let's say, take an example, separating a mixture of salt and sand. Let's say this is the two things we have to separate. Now salt and sand can be separated by first adding water. Simple method. Once you add water, salt will get dissolved, sand is not going to dissolve. So this is dissolve, right? Dissolve in water, whereas sand, they are not going to dissolve, right? So when the sand is not going to dissolve in water, that means you can easily separate the sand, right? Is it? Then later on we can think how to separate salt and water, right? So you can say here that salt and sand can be separated by first adding water, right? So what is going to mixed? Only sand, only salt. So only salt dissolves. Then what is the next step? So when you are going to filter it, you will get the sand on the filter paper, and let's say this is a solution, right? So in this solution you have, right, you have solution here, and something will be at the base, right? Let's say some heavy particles. Let's say this is salt. So when you will filter it, you will get sand crystals, right? These are the sand, and you will get a solution, right? And this solution have salt water, right? Because salt is mixed in water. So we can say that when the mixture is filtered, the salt solution passes through as the filtrate, right? And the sand stay behind as a residue. The sand stay behind as residue, right? So residue which is left back. So this technique works. Why it is working? Because of the solubility. and solubility is one of the physical properties, right? So can we say that this technique works because the two substances have different solubility, right? Different solubility in water. Imagine a situation where both are going to get soluble. Then it will be difficult, right? So the water from the salt solution uh, how you will separate the salt from the solution by evaporation. So we can say that the water from the salt solution can then be evaporated to get salt. So yes, there is a possibility we can get the salt, but sometime we have to apply some physical properties. We have to use that physical properties to separate them, right? So let's talk about how we are going to separate all the mixtures. Let's begin. So we are going to discuss about separating mixtures. Right? When we talk about separating mixtures, the choice of the method of separation depend on the nature of the substance being separated. All methods rely on some kind of difference in the properties. Then only you can able to separate the substances, right? So we'll talk about how to separate solid, how to separate two liquids, and how to separate two gas, right? So let's begin with the separating mixtures. The choice of the method of separation depends on the nature of the substance being separated. What you are separating, that is very important thing to know. And when we have to separate something, we have to use that physical property which is different, right? So we can say that all methods rely on some kind of difference in properties of the substance being separated. Now when we talk about properties, what are the properties? So you can say this is usually in a physical property. Physical properties like boiling point, melting point, right? Or you can say solubility. So these things can be used to separate the substances, right? So let's talk about how we are going to separate the solid substances. So separating a mixture of solid. Right? Now if you want to separate a solid, right? So we have to think in terms of their boiling point, melting point, right? We have to discuss about see the difference in the solubility of the substances, right? So these things will help. So we can say difference in solubility can be used, right? Some are least soluble, some are most soluble. So based on the solubility difference, we can separate. Can be used to separate solids, right? So let's talk about a method, solvation. Solvation, what is solvation? Solvation is a process where a solute dissolve in a solvent. Let me write the definition. It's very important in IB that you must know the definition in a very clear form because IB asks definition. So you can say solvation is the process where a solute dissolves in a solvent. Now why they're getting dissolved? Because of the solvent properties. Because solvent properties, sorry, solvent particles surrounds and attract the solute, right? Solute particle. So until unless the particles are not approaching, then things are not going to get dissolved. Like just now we have discussed about um, separating sand from water. Separating sand from water. Just now we have discussed this example. So this is a very basic example. So what steps we are going to follow? Add a mixture to the suitable solvent. You have to stir it so that it get dissolved. Insoluble substance will remain undissolved, right? And the soluble substance forms a solution with the solvent, and what is not mixed can be easily separated. So steps are very clear. If you want, I can write the steps. First, add the mixture to a suitable solvent. You can take water here, right? Next step, stir to help the soluble substance dissolve. Right? Now what the next step? Something is not dissolved. So you can say insoluble substance will remain undissolved. And those which are not dissolved, now you can simply remove it out through filtration, right? So the soluble substance forms a solution with the solvent. Right? So things are now very clear, like how we can separate what is solvation and what are the methods, what are the steps involved in solvation. They can ask in multiple choice which method is right. So in water, when you are mixing something, that's called hydration. Always remember, let me write here as a note point. So I can say in water, this process is called hydration. Fine. Solvation is essential for separating techniques like we use um, crystallization, filtration. Right? So I can say solvation is essential for separating techniques like filtration and crystallization. Right? So these are very important.